We have an assembler for the R32V2020. Let's take a look at the workflow. In this case, the assembler is loaded into the tree that's in GitHub, and it can be found up there. It's a Python program, so you need to have Python installed to run it. The program loads the opcodes as it runs out of a table, the mapping of the opcodes to the bits that are used for the actual hex file that's downloaded to the part. But basically all you have to do is run it from a command prompt and it will compile the code. Code has two sections in it. First section is the things that go into the data memory, like in this case a fixed string R32V2020 caret space, and then it has longs, shorts, bytes can also be stored into the space. Following the data space is the instruction space, and that's the assembler instructions, and they match the programmer's reference card from the previous video for what they do for function. For instance, BSR will do a branch to a subroutine, and the subroutine that it'll branch to is a clear screen subroutine in this case. And that subroutine pushes things onto the stack and sets up addresses and sets up counts, and in this case fills the screen with spaces until it's done. At the end, it pulls the program counter back off the stack after it's unpeeled the things that it pushed, which then returns back to the function itself. So we have subroutines working. Everything is working that's on the programmer's reference card at this point in time. It's kind of a good moment. I've checked it into GitHub with an archive version of it in case I mess it up, and it can be found up in GitHub, and I'll put a link down in the show notes for it. So basically you just write your code up there, and then down in the bottom section here in the command prompt, just in DOS, you just go ahead and assemble it. And if there's any errors, like if we'd had a typo up here, like I'll insert something that's wrong here, it should come back and tell me line 10 that that's not a label that it knows about. Let's see what it does in that case. Yep, it came back and said line 10 doesn't know screen 5. So, oh, there's a typo. So let's fix that and go ahead and compile again. And it compiled successfully. To download the code to the card, if you double click on the block ROM, instruction ROM, go forward 2 pages, and then browse through the tree down to VHDL programs, and this particular program is the 060 program, and then select the INS as the instruction segment, the DAT is the data segment. Select that, finish, and do the same thing for the data. Go in 3 clicks here, takes you to the file selection, select the file there under programs. Got quite a few example programs all running up here. Select the data, finish, and then tell it to compile. The assembler produced the .dat or underscore .dat.hex and underscore instruction ins.hex files, which are what was downloaded to the card. These files are formatted as hex records, which you can look up Intel hex if you want to understand the formatting of it. The files, or the VHDL FPGA code, takes about almost 2 minutes. Right now I have signal tap on, so it's a little bit longer. I've got a quad core 3.6 gigahertz Xeon machine, and I've run it on newer i7 machines, and it doesn't take much less time. I think I've run it on single core machines, and it's probably 20-30% slower. So there's some advantage to running with multiple cores, but it wasn't the big advantage that I thought I would see with buying a higher speed older machine. To download the code to the card, I double click on the program device and then hit start, and it programs the card, and up comes the R32V2020. I'm running PuTTY to communicate with the card in the serial port, and I can type on the keyboard and it will go up on the screen. Backspace works currently. I can't see the screen as I'm typing, so there's probably typos up there. Enter works. And Control G makes a buzzer sound, which you can probably hear, kind of annoying. It also echoes everything back to the PuTTY terminal. My son Michael wrote the assembler, and he's an excellent programmer. I want to make sure I give him credit here. I'll put a link down to his YouTube page. He's got a lot of videos he's put up on programming, and if you like it, go ahead and check it out and subscribe. I'm sure he'd enjoy having more subscribers. If you want more information, you can see our wiki pages for these products, and we have YouTube videos on them as well. We have a store in Tindie where we sell all of our cards. Thanks for watching our video, and if you enjoyed it, don't forget to like, share, and subscribe.